In this question, for this series, we are using the integral test to determine if it is a convergent or divergent series. Okay, for that, this is the general term. So here we got the generic term. An is cube root of n plus 2 over n squared. Then we let the corresponding function just replace n by x. So cube root of n means cube root of x. Let me write in this way: x raised to 1/3, same thing, plus 2 over x squared. Now to apply the integral test, we need to show three things. F should be continuous on the interval. Look at this sum, it starts from 1 through infinity, so it should be continuous, and the function should be positive, and the function should be decreasing on all three things on 1 through infinity. Okay, if that's true, then we find the improper integral of fx from 1 through infinity. If the improper integral converges, this series converges, and vice versa. Okay, continuous. Okay, x power function x raised to 1/3, this is always continuous, plus 2 always continuous, and divided by x squared continuous, so the ratio is also continuous, so no question about that. Positive, for x positive, because we are working on 1 through infinity, so when x is positive, its cube root is also positive, plus 2 positive, square positive, so whole thing is positive. That's true. For decreasing, okay, in general we are supposed to find the derivative, use quotient rule, and show that the derivative is less than 0 on 1 through infinity. Okay, but I want to give you some idea. This is the general method, but let's make this observation. Okay, plus 2, when x is very big, plus 2, it doesn't matter. Okay, now the question is, which term grows faster, x raised to 1/3 or x squared? Obviously x squared grows faster. When we take x equals, let's say 1000, so 1000 is squared, 1000 1/3 is just 10. Okay, when x increases, the bottom grows faster than the top, so overall the function decreases. Okay, so this is also true. Then we can use the integral test. Now we find this improper integral 1 through infinity of function x 1/3 plus 2 over x squared dx. Let's find this definite integral in this way, improper. So this is infinity, so we need to take the limit. T goes to infinity of 1 through t. At the same time, to evaluate this integral, we have two terms on the top, quotient, so I want to split into two fractions. X raised to 1/3 over x squared plus 2 over x squared dx. Okay, let's find this definite integral and take the limit. Okay, we go from 1 through t. Okay, x raised to 1/3 divided by x squared, 1/3 minus 2. Okay, let me do over here. Okay, so x raised to 1/3 over x squared is same as x 1/3 minus 2. Okay, 1/3 minus 2, which is 2 is 6/3. 1/3 minus 6/3, negative 5/3. And we want to find the antiderivative. It's like xn, so x n plus 1, negative 5/3 plus 1, negative 2/3, divided by same thing. So the antiderivative of first term is, when we take negative 2/3 to the front, it becomes negative 3/2 x raised to negative 2/3. Okay, plus, let's work on this. 2 is 2, it's 1 over x squared. Okay, let me erase this part and find that integral. 1 over x square is same as x to the negative 2, and xn plus 1 divided by n plus 1, so negative to the front, x to the negative 1. So 2 times negative 1 x to the negative 1, and we need to get rid of these negative exponents. Let's put them on the bottom. T to infinity is negative 3 over 2. Let's put x on the bottom. Negative 2/3 becomes just positive 2/3. Positive, negative, negative, 2 on the top, divided by x to the negative 1, just x. And we need to evaluate from 1 through t. Okay, let's evaluate this function, then we take the limit. T going to infinity. Replace x by upper limit minus replace x by lower limit. So replace x by upper limit part minus lower limit. Negative 3/2 x is now t raised to 2/3 minus 2 over t. Okay, that's the upper limit part, minus from the fundamental theorem of calculus. Now replace x by 1, so negative 3/2 times 1 raised to 2/3 is 1, so just 2, minus 2 over 1 is 2. Okay, now simplify, at the same time let t goes to infinity. So 3 over 2 t 2/3. When t goes to infinity, okay, this factor goes to infinity, and 3 over infinity, 3 over very big is 0. This part is 0. Same thing here, 2 over infinity, very big, 0, minus there is no t involved, so negative 3/2 minus 2, both are minus, negative negative, so we can add. 2 is same as 4/2, negative 3/2 minus 4/2, negative 7/2. So negative 7/2, negative negative positive, so we have just 7/2, which is a finite number. That means this improper integral converges. In turn, this series converges. So I will write here, this series converges using the integral test. Here is the proof, or here is the workout.